Alright, we're going to do a thing. I don't know what this thing is yet, but I've got a knockoff wireless PlayStation 2 controller, and I've got an Arduino. So I'm going to make this guy talk to this guy somehow, and then I'm going to be able to control some thing with the PlayStation controller. I don't know exactly how this is going to work yet, but I do know a couple of things straight off the bat. These old PlayStation 2 controllers is just basically a standard PlayStation 2 controller, except instead of a cable going to this connector, which would normally go into the PlayStation, there's a little wireless radio that connects these two instead. But these connector pins inside here work the same way as the connectors on a normal PlayStation 2 controller work. The nice thing about them as well is that they basically work on a really simple serial protocol. So some of these pins are the data pins, and there's some power pins and stuff like that. So if I wire these up, I should be able to connect them to the serial port on this guy, and they should be able to make them communicate. I think there is a library that does most of this for you. So most of what I have to do is just really figure out what the pinouts are, and then I'm probably going to write a wrapper that goes around that library to give me some nice, easy convenience methods that I can reuse in the future for making, this be able to work with any type of, robot, anything I make in the future, any machine. So one reason why I'm going with this as well, instead of using other methods where you've got, radio modules and stuff, is that this will be pretty reusable, pretty easy to do. So if I can model, a socket that size as well, and maybe 3D print it, I can integrate that into multiple projects, and then I can just pop this guy in and out of multiple different projects and control stuff with the same controller. I don't know how well this is going to work out, but we'll see what happens. Hopefully if I can write a nice library that gives me some easy abstractions around this. Maybe I think the library that does the comms, maybe it'll already have some kind of nice abstractions around it. I haven't really looked into it too deeply, so yeah, that's what I'm going to do. I'm going to show you how the wiring works, how I'm going to design a little module for this to plug into, and yeah, we'll go from there. And I have no idea what I'm actually going to end up controlling. I might just flash some lights or something. I don't have any robots to hand to integrate it into right now. This is in it, but yeah, let's do it. Okay, so I managed to do a little bit here. I have my Arduino Nano and this breadboard. I have some jumpers, and I have the little wireless receiver guy here with some of the pins identified. So there's 9 pins in total inside the little receiver, which is the standard PlayStation 2 and PlayStation 1 plug setup. 9 pins, 2 power pins, 5 volts, 3.3 volts, and ground. Then the rest of the pins, there's 1 pin here, another power pin here, which is usually used, the 3rd pin in is usually used on the normal PlayStation, which is the wired one, as a power supply for the rumble motors inside this. So the little motors that have these centric weights on it to make the controllers vibrate. That's a separate power supply usually, which directly feeds them. I don't know in this case if having that connected will do anything, because this is a wireless controller, so there is no direct feed to the motors. I assume, well, it has to be that the motors get powered by the batteries here, but I don't know if in this wireless receiver that you have to put power on that for those to turn on. So I don't know if there's like a 5 volt, like a high signal goes on there, will that trigger the guys in there? I haven't figured that out yet. But anyway, yeah, the rest of the pins, then there's 1 pin that isn't connected here, and there's another pin, can't remember what it does, but I don't think it's necessary. And the other stuff is you've got the 2 main data pins here, which are the so for SPI interface, they're essentially MOSI and MISO. So it's they call them data and command. So one is communication from and to, and to and from. So then the last 2 pins that are left are clock pin and what they call the attention pin, which essentially behaves the same as chip select or cable select or slave select, whatever way it's labeled up. So I have those connected up. I've got the power connected to the Arduino, supplying it with 5 volts. It says 3.3, but I actually found that it worked better with 5. I don't know what that's about, but yeah, I give it a 5 volt. It seems to be working fine. So then I have that is the, what is that pin? That's the slave select pin on the Arduino, and then I have the other, which that's the clock. Then I've got the slave select, and I've got the Mossy and Miso all set up, and it works, shockingly. So if I plug in the Arduino, got power light comes on, and then if I turn on the controller, our controller is connected. There we go. And yeah, it is, type of controller is DualShock. We have the analog stick values, and as I move the analog sticks, we get changing values. As I press the buttons, we get, we get a whole mess of outputs. So this is basically sample code that's provided with the library that I found, which is, there is an original library, I can't recall the name of it now, but the one I'm using is called, I think it's called PSX New Lib, which is a new version of the library, which is based off of the old version of the library, which is no longer supported. I think you can still download it and install it manually, but this appears to be the most maintained, up-to-date version of the library. So this is what I'm basing it off of. This is just some sample code, slightly modified sample code to give me some other little bits of functionality. Yeah, so that's about as far as I've gone with it. The next thing I need to do is, on the code side, I want to make a nice kind of wrapper that will wrap this whole thing up so that I can give, I can assign callbacks to these button presses, so I can identify when a button is pressed. I'd like to be able to have, you know, a callback, which would be, you provide maybe a function pointer, and then it'll call that method in your code, and maybe wrap that up in a library. So it'll be nice. That's one thing to do anyway that I want to do. The other thing is I need to come up with a more robust way of connecting this. As I mentioned in the last little, in the introduction section, that what I was going to do was I was going to maybe design, 3D print this, and have like DuPont connectors maybe inside it that would match these. I found that they don't actually connect all that well, so I'm not going to do that. I'm going to cheat a little bit. So I originally found that I found online that you can buy little breakout boards for these, which are just the socket side of this with some pins, and it's all soldered up, so you can just click cables onto it. But I did find that those are, I couldn't find them on Amazon, they're all out of stock, but then I found some other ones, and they were ferociously expensive. Not ferociously expensive, but you know, they were a little bit more expensive than, you know, wanting to spend that money to put one into every single, you know, little robotics project that I might make in the future. So I found this guy on Amazon for very, very cheap. This is a 2 controller to USB splitter cable. I think this costs €7 maybe for this, and with it I get 2 sockets essentially. Previously I had ordered, for this project I'd actually ordered an extension cable, controller extension cable, which would give me one of these anyway, but it actually didn't arrive. It was on its way from China and seems to have gotten lost, so I don't have that. But I have this, so I have 2 of them now, which is handy. So hopefully what I will be able to do is I'll be able to, if I unplug all these, yeah, so this should just plug straight in. There you go. So now that is a nice positive connection, and it's nicely reusable as well. So I can, what I'm going to do is I'm going to cut these cables. Well, I'm assuming that inside this box it's doing all the serial conversion, so all the pins will be connected through wires into this that goes into here, which does some magic to make it USB. So what I'll do is I'm going to cut these off, strip back the wires, identify each pin, and I'm going to put little maybe a 6-pin, I think there's only 6 wires I mentioned, I'm going to put maybe a 6-pin DuPont connector on the end of it. So then that'll be these reusable little plug modules that I can use for different projects in the future, which is pretty handy. So yeah, I'll have 2 of them for not very much money. So that's my plan anyway. Yeah, so I'm going to do that. I'm going to cut the cables, try to identify which cables are which, and set them up, wire them up with some little DuPonts, and then hopefully get rid of this messy set of wires. And then I can do a bit more work on the software later. Okay, I made a little bit more progress with this. Basically what I've done is I figured out more or less how it transfers the signals from the button. So the problem I was having with the library, or the sample code that's provided with the library, is there's a bit of abstraction in it that was confusing me. So what I've done is I've ripped out most of that abstraction, left just like the bare essential pieces, and broken it down so that I can pretty much have functions now that are mapped to when the buttons press and when the analog sticks are moved. So at the moment I haven't gotten, the plan is that I want to make it so that like you can write one function in your Arduino code, and when you press one button it'll call that function. And so I haven't quite gotten that far yet, but I've gotten pretty far. So the analog sticks are pretty easy. There's a function now I have that exists. You can see it here for the left and right analog sticks. At the moment all it does is it just prints out their positions, the X and Y coordinates, that's actually part of the pretty much stock from that example code that I was able to use. The buttons are a little bit trickier, but essentially throughout all that abstraction, basically what happens when the button gets when a button gets pressed, it sends a 16-bit unsigned integer over the serial communication, and that's what you see. So basically each button press corresponds to one bit of that 16-bit. So there are 16 buttons on this. You've got the 4 D-pad buttons, you've got the square, triangle, circle and X buttons, you've got your 4 shoulder buttons, and you've got the 2 buttons on the thumbsticks when you click them down. The mode button on this controller is just that doesn't matter. That's only specific to the actual hardware of this controller itself. So that is pretty much all we need anyway to be able to determine what buttons are pressed. So I was struggling while I was thinking about how do you do a hold, like a long hold on a button. But essentially, if you just continuously check the state of the controller by asking what are the things, you get this word back, which is just the 16 bits. So if a bit hasn't changed, so you know that if the state of a bit hasn't changed in the 16 bits, you know that the button's being held down, because if it hadn't, it would have changed from a 1 to a 0. So yeah, you can see there that as I hold down a button, it stays the same between each state change, and as you release a button, you get a new word, which represents essentially the 0 state of the controller with no buttons being pressed. So that's about it for now. Next thing I'm going to do is I'm going to try and wire up some functions to do something, and I actually have some little bits of hardware that I have built out that I have gotten for another project, so I'm going to wire them up to this and just see if I can make them do something with the the button presses from the controller. Okay, it's demo time, but before demo time we're going to have a little story time, because I messed up. So the eagle-eyed among you will notice that this PlayStation 2 controller and dongle are different color to what you had been seeing up to now in this video, and that is because I managed to fry the little dongle, and that is mostly thanks to, well, can't say it's thanks to this little guy, but it was caused by this little guy and mostly caused by me. So for the demo, basically, I just wanted to set up to control this little motor. This motor and driver are for another project that I have coming up, so I figured it's a good time to just wire them up because I'd never used them before, and use that as a little demo thing, and also kill 2 birds with 1 stone and just get used to how this thing works. So I did some silly things. Basically, this driver board is pretty much as a fancy H-bridge where I can supply power that's going to power the motor, in this case 12 volts, connect up the motor which will be supplied with 12 volts, and then it gives me this series of pins. Sorry, it also has 2 channels, so I can control 2 motors at one time. It gives you this set of pins, one for channel A and one for channel B, and a few different outputs and inputs that you connect up to your microcontroller. So this is a bit of a cautionary tale as well about using parts from Amazon that don't have data sheets. Basically, the parts from Amazon, no data sheet. Couldn't find any real information on online, so sort of dug around with what I know about how H bridges are supposed to work and started connecting up wires. And that's when I did a silly thing and essentially fried the old Arduino Nano I was using, fried this guy, and almost killed my laptop by connecting 12 volts straight into the 5 volt line of this Nano, which there's 2 ways that can happen on this thing. So, you know, a lot of motor drivers and stuff like that, the output side here is 12 volts, but on these pins you don't usually always get that. Oftentimes it's either there's a regulator on the board that gives you a logical 5 volt, or you're supposed to supply the logical voltage from your microcontroller to this, and then it knows what its voltage levels are supposed to be. So in this case, I connected up my 5 volts to the V plus terminal on this, which I now know happens for this board to match your supply voltage that you're giving it through here, which is 12 volts in my case. So as soon as I connected all that up, the whole thing was fried. Turned on the power supply, my laptop dramatically turned itself off and smelled smoke burning from the Arduino, and this little dongle also happened to be fried afterwards when I reset with a fresh Arduino. Thankfully my laptop survived, just hard reset itself, but I rebooted it, seems to all be working fine. So that one I can kind of get. The V plus pin sort of makes sense that it would be, 12 volts if that's what you give in the power supply. I mean, I can't really argue that it wouldn't be match some supply voltage that's on the board. The one that surprised me though was there's an enable pin on the board which allows you to turn on and off all the H bridges. It's defaulted to on, so that pin is reading what is the logical high voltage for on, 13.5 volts, which that really surprised me. So that's the 12 volts here plus a little bit extra for whatever reason. But yeah, really, really strange. Maybe that's common. Maybe people who know more about this will have thought, oh, obviously that's the case. And also, I shouldn't have just plugged it in. I should have connected the power and measured each of the pins as well to see what was on them, and then I would have known straight away not to connect any of the high voltage pins there to the Arduino. So the 3 pins I have here connected, there's a ground and 2 what are just inputs, so they're all safe to connect and they'll accept the 5 volts from the Arduino to drive the motor, and then the ground is just a common reference, so it's all good. So yeah, that's a very roundabout story of how I blew things up and why this is now purple. But I do feel that purple is probably more on brand for me, so that's good. So anyway, what we came here for, the demo. And now this is going to be so impressive to everyone. Look at that. It moves. So I'm pretty happy with that. I mean, it's nice. I've got a pretty clean way of controlling it. And the code that does it is also pretty straightforward and quite clean. So, I did say in my earlier videos that, or the earlier part of this video, that I was going to make a library for this that people could download and just plug in your own callback functions and stuff. It actually turns out I don't have time to do that, but I'm going to post up this code anyway. I'll put a link in the description where you can find it. It's pretty straightforward, and you can take it as it is and just plug in your own functions and stuff to make it work. And yeah, it should be pretty straightforward to use. If you have any questions on it, you can throw them in the comments, or you can reach out to me via my website or whatever. And yeah, I'm happy to help. So the other thing though, the reason why I don't have time to do this is I have been asked to exhibit at the Dublin Maker Festival, which is coming up at the end of this month in Dublin, Ireland. So I'll be exhibiting at that, and for that I wanted to make a new machine, which is why actually I'm under a bit of time pressure to get that machine working and what these parts are for. So I'll be hard working at that for the next month, and I don't have time to really work on anything else because I've never had to do a timeline before for one of these projects. So yeah, I'm going to be doing that. Yeah. So I think that's probably about it for this video. If you liked the video, don't forget to like, subscribe, share with your friends. If you want to help support the work I'm doing, you can find a link in the description to my Patreon. And if you're around Dublin, if you live in Ireland and you're around Dublin area, you want to come and see, I think it's the 23rd of July in Merrion Square is a Dublin Maker Festival, open for everyone. And yeah, come by, I'll have a stand there. We can chat, and yeah, you can see maybe what this turns into. So yeah, that's it for now, folks. Thanks for watching.